Hello, welcome back to the series on static mechanics. We are taking a simple question to text the concept we talk about and the equilibrium of forces. So a particle is at rest and the actions of three forces, two of which are given as P and what Q. We are to find the third force. So if the particles are at rest, it means the vector sum of their resultant forces will give you what? Zero. So first thing first, let's say we let the third force. So we're having PQ. Let's say the third force is what? R. And if the forces are in, okay, let's just say are at rest, it means that the first force plus the second force plus the third force to give us what? Zero. And in order to find them, the forces are in magnitude direction form, so we convert them into vector column form. So we can say that, what did I say? Resolution of forces. So let's resolve the first force, which is P. How do we resolve that? We take the magnitude, multiply the sine of the angle to get the x component, the magnitude multiply the cos of the angle to get the y component. So we put that on our calculator and find the component. And if you do that, the first component will give you 4, not 2. Then the second component, when multiplied, will give you 3.46. It is still 4, so we add a new thing. Let's get a Q. The magnitude for Q is 10, so 10 times the sine of the angle 300, 10 times the cos of the angle 300. So let's resolve that into vector component form. So as you multiply that, you still have negative 8.67 and 5 on the y component. So this is what the values will give you. Now remember, you are looking out for the forces in equilibrium. So if I have P plus Q plus R equals 0, I can rewrite all of them in their vector form, which will be 2, 3.46 plus negative 8.67, 5 plus R equals to, let's just say this is a 0 vector. So if that is the case, we can add this here and send it there. So what will happen? Let's say we have 2 minus 8.67, 3.46 plus 5. This is a plus. This negative take effect of that, plus the R equals to the 0 word vector. I think we subtract this to be giving you negative something. So here you should be having negative 6.67. When we add this, it will be 8 point something, right? So that will be 8.46 plus the R equals to 0 word vector. Now we are looking for the R, so we transpose this vector to the right. As it is being transposed, the positive will become what? Negative. So right from here, your force R will be equals to, let's transpose this and just have positive 6.7. This become negative 8, 4.6. As it transposed, that is what you get. So let's see, we need the magnitude of R, which means that we find the square root of the square of the first component plus the square of the second component. I think we can put all these in a calculator at once and find what the value will be. If you find the square of this plus the square of this, that will be giving you, okay, we have 116.06. Then this will be almost 11, right? So this will give you 10.8 Newton. Remember, doing this, we are getting just the magnitude. The forces we're given were in magnitude and direction form. So we need to find the direction of the force R also. So to find the direction or the bearing of what? Force R, we are going to indicate this in our Cartesian plane and find the acute angle it forms with the x-axis. So we see this is x-axis. So this is the x, this is the y. So if x is positive, I'll be on this line. If y is negative, I'll be on this line. So let's see. So if I have the point here, the point for x is there, forming 90 degrees. This is the angle we are looking for. Then this is parallel to this, so the reading on the y-axis is 8.46. The reading on the x-axis is 6.617. So in order to find the, okay, let's take it there. We are going to find the tan of, this is going to be opposite. So from the diagram, we can only see that tan theta equals to the opposite side 8.46 divided by the adjacent 6.67. I think fast forward, we can have our theta to be equals to the tan inverse of the 8.46 divided by 6.67. We put all in the calculator and see the value that you will get. And that will be giving you 52 degrees. That is to the nearest whole number. But remember the measurement of a force. This is the force we are looking for, force R. This force R is measured from the north down to this place. So the actual direction, so the actual direction measured from the north is going to be, from the north, you will get this angle first before you come to the theta. So that means 90 degrees plus 52 degrees, that will be 142, I guess. 10 plus that, so 142. So therefore, the third force is going to be, which is what do we use for that? We use R. So R will have the magnitude of the force, 10.8 Newton. So 10.8 Newton. Then the direction will be 142 degrees. So this will be the actual representation of the force that is the third one that makes the first two forces to be in equilibrium or to be at rest. So you can see we are only texting all the concepts we did under the equilibrium or for coplanar forces. I think we'll still pick one or two examples, then we move on to three forces in equilibrium, exactly three forces in equilibrium. Thanks for watching. Like, share, comment, and subscribe.